said it a half dozen times. I'll just point out that if you go into test topics, practice problems, and solutions, there's a whole bunch of stuff right here. I've been asking people to look at this. My guess is people maybe have not. Let's go ahead and check that. Oh, did I not do that? No, I did. All right, while that's running, I'll just point out the specific documents there. And again, if you haven't looked at that, I'm offering you the chance to, I don't know if we'll have time at this point to do review, but offering you the chance to ask some review questions. If you go here and look at test topics, I've got detailed lists of the topics of what you should know for this test. And then I went ahead and tried to post some review for different pieces of the course. So things about limits, things about continuity, things about rates of change. I'm happy to look at any of those things if you're interested in doing that. Wonderful. According to this report, some folks have actually downloaded that, which is wonderful to see. I should say 1, 2, 3, 4, 5 people have downloaded it a bunch of times. So thank you for the 5 people who are trying hard. And I would really love to answer any questions for anyone who has questions about that stuff. Looks like someone said something in the chat. Would you have the blanks limit review sheet? If you did, can you post that? I do not have the blank one. So yeah, what I would suggest you do if you download this review sheet. Yeah, this looks like I completed it, but I actually didn't do this. I found this online and it looked like a bunch of good problems. And so what I would just do is just write this problem down on a separate sheet of paper and see if you can do it there. I apologize, I don't have that blank one. All right, I'm gonna get started with the notes. But anyway, I wanted to point out the review stuff. There's tons of stuff here. Almost no one's looked at it, but thank you for the 5 people who have. I'd be happy to answer some questions about that. If people want to ask some questions later today or tomorrow, that would be fine too. All right, I'm gonna keep going with the notes here. Keep trying my hardest to teach the material. I suggest you write this stuff down because it's part of the course and it'll help you be successful on quizzes and tests. Try to provide that disclaimer as much as possible. So as a quick review, we've talked about rates of change in a couple different ways. Primarily, let's see, where is it listed? Where does it list it? So I guess this is a good way to look at it. We've looked at the average rate of change, right? And the instantaneous rate of change. And we've looked at the formulas for both those things. This is the average rate of change formula right here. And when you throw a limit on that, it becomes the instantaneous rate of change formula, right? This one right here. We're just going to extend this concept a little bit to another formulation of that and remind us of some of the things we've learned, right? So far we've looked at the average rate of change. That's kind of like the slope between the 2 points, kind of like the slope formula. If you remember that, that's kind of simple. And then when you throw a limit on there, it becomes the instantaneous rate of change, right? And that's really the focus of calculus. That's what's known as the derivative, right? We've seen this notation a couple of times. The function with the derivative on there, or the prime number on there, that's the derivative of the function at the point B. And we say that's the instantaneous rate of change at that point. And I just want to remind you of the interpretation of that before we jump back into actually calculating it algebraically, right? That's sort of thinking about like how steep the graph is at that point, right? So that's what it says right here. F prime of B tells us the slope of the tangent line. So if this is our graph, let's try to draw the same graph twice. We've kind of seen this before, but it's, as we've seen, can't write it down too many times. Hopefully if we write it down enough, everyone will get it written down eventually. If we care about the point B, right, one of those points is to the left of the hump, so it's still on the upward incline, right? And one of them is to the left of the hump, and so it's on the downwards incline. Now, what the derivative tells us is it tells us the slope of the line tangent to that point, right? So here is f of b in that location. And let's throw some tangent lines on there. All right, so I'm trying to draw a line that's tangent to those points. And the word tangent just means that it just barely touches that point and only that point on the graph. Right, and so one of them is clearly going up and one of them is clearly going down. And so if you can't sort of see that the graph is going up, just kind of looking at that point, we can just throw a tangent line on there and see it pretty clearly. And so the thing we're kind of moving into, you know, we have these limit formulas and stuff like that, but the thing we're moving into is this notation f prime of b, excuse me, and that tells us the slope of the tangent line to the point f of b, right? So this, when I say the tangent line, I mean the blue one. And what I'm just trying to remind us of is if we're in a part of the graph where it's still going up, like the one on the left, that's going to be a positive rate of change, right? So this right here is showing a positive slope at f of a. Thus, the function is increasing. Right, so sometimes questions you see in homework or tests or whatever is just like, here's a derivative. Does this mean the function's increasing or decreasing? Right, or a question I could put on a quiz is, you know, I could draw this graph on the left here and just say, is the derivative at b positive or negative, right? And you would just need to connect in your brain that means, is the function going up or down? And so just to kind of be complete here, the one on the right then is showing a negative slope at f of a. Thus, the function is decreasing. And so this is, you know, I hope it's not, doesn't feel too basic. I hope that makes sense. But the point here is we use this information because somewhere between those two locations, the slope was 0, right? Like right at the top of that peak, we have a horizontal tangent line. And that becomes a very important point in the next section in finding maximums and minimums and classifying them as such, right? So that's what we're sort of previewing here, right? So this slope is negative. This slope is positive.
Sorry, I have a quick question.
Yeah, go ahead.
This is positive slope at f of a, but the graph says f of b.
Thank you. Where did I write f of a? Yeah, that should be f of b. I did it in both of them. Oops. I did it 3 times. Sorry about that. Everyone see that? I just changed this, and this to b's. Thank you for pointing that out. Other things there?
Yeah, so the point of this is to find, like, both finding the increased slope and the downcreased slope is to find where the slope is 0.
That's going to be a later application. Right now, we're just sort of thinking about the implication of the derivative, and what I'm sort of pointing out is in the next section we use that to find the peaks. If you've taken calculus before, you know what I'm talking about. But sort of the interpretation at this point is like, if we had a function and we knew the derivative was positive, we just know it's increasing. And so if it's like a population function, we know the population is going up, right? And so that's helpful to know how to prepare for the future. If we know the population is going up, we need to do certain things or whatever. That's all I'm sort of implying right now. And just previewing the next section is where we use that to find maximums. Maybe 2 sections from now. Yeah. Other thoughts or questions? Okay. And so we've calculated this. This is mostly a summary page. Sometimes I don't feel like I say the same thing over and over, but sometimes that's needed, right? And sometimes it's helpful to, you know, summarize 3 or 4 pages in one page. And so that's what's also happening at the bottom of this page. It's summarizing the different ways we've talked about so far about how to calculate the slope, right? So in the last section, like it says right here, in the previous section, we used this method for calculating the slope. And that's what the homework is going to be on, or that's what the homework that's out there that was originally due tonight is on, that I extended to next week because I felt like we didn't maybe go into it enough. And what I'm introducing here is this new way to calculate the derivative, right? And notice the difference between these two formulations. This one is f prime of b, and so that's at a specific point. And so let me write that down. So that's pretty relevant. This particular one gives a numerical value for the rate of change at specific point. And the specific point here is b, whatever b is. Right, and we saw this, we calculated some previously. I'm going to just slide up real quick. I know people are probably writing this down still, but just to slide up and show you this, right? That's what we did right here in this Kingfisher example, right? We had this Kingfisher example. We did the instantaneous velocity, and we did this limit, we did this thing, and we found that at that specific time, the bird was traveling down at 10 feet per second, right? So again, that's a specific numerical value. It tells us something specific, and it's a number. That's different than this new thing I'm introducing, this new limit thing that I'm highlighting here. Notice how there's an x in this one, right? It's not at the point B, there's an x in there. And so this is going to be a function with an x in it. And this is nice because this will tell us a function for the rate of change rather than at a specific point. And that's nice because then we can calculate the rate of change anywhere. Right, so this one that I'm pointing to right now, this will give a function. So it's going to have an x in it. And that will let us calculate the rate of change at any point. In other words, we can just do the limit thing once, get a function, and then plug numbers into the function. And so we haven't seen that yet. And so that's kind of the focus of what I'm trying to look at in this particular class, is that function and how we evaluate that function. Because the x plus h part, this part right here that I'm highlighting in green, is usually the thing that confuses people. If there's something about this that confuses them, it's always that term. And if you had me in pre-calc, I focus a lot on that term when we look at compositions because I know it comes up in here. Okay, did everyone hear me okay? I feel like my internet's crapping out on me all of a sudden.
No,
I'm
you're
okay.
good.
Okay. It's not. Okay. I think my iPad is messed up. Let me check that again. Okay, seems okay. Questions about what I'm trying to say about the difference between those two things. So far, we've seen the first one. We're about to dig into the second one. And I'm going to present a third one even in a second. But are there questions about those first two? Okay, so what I'm saying right here, then, the next part, if we just plug b into there, into the x's, so those three x's, we plug a b into there, then we get a new expression, a third expression that we could potentially use, which would be this. And I forgot to plug the b in. There should be a b right there. You guys hear that tree being cut down right outside my house?
Oh yeah, it's not like
Chainsaw. Yeah, it's a great time for that to happen. I've been watching them all morning climb up there, and they like just started at 10:45. Okay, so this is now, maybe I'll highlight it in red again, outline it in red. This is even a third way to calculate the rate of change. I don't want to get too overwhelmed here, but that's f prime of b again, right? So that's going to be the same thing as the first thing I looked at, which is like this one. So I just drew an arrow from the third one up to that blue description, right? Because this one's also f prime of b. And so this one is this is going to be a similar calculation to that first one. It's just a different way to look at it. But the new thing is the middle. And so we're going to focus in on the middle. And can I clarify what I'm saying so far, though? And again, this is just a nice way to have all three of those things just listed on the same page and try to give some clarity about the difference between them. Is it okay before we sort of focus in on the new one?
What's the difference between the first one and the second one? Why is the first one telling us specifically at B if the second one is also f prime of x? Why is the first one specific and the second one gives us a function?
Yeah, so let me maybe draw a quick picture and see if I can clarify that with a picture. So let's say this is the function we want to calculate the derivative of, and let's say the point we're looking at is this one. There's our b. The first function, the first one, if you remember, it like takes a bunch of x values and then it makes them get closer to that point. And so you do this rate of change thing that gets closer and closer. Oops. It gets closer and closer and closer to the actual thing until you actually hit the limit. And then it tells you this line that we really want, right? So that's what we had learned previously. And that's allowing x to approach b. So you're like moving closer to b on the x-axis. On the other one, what you have is x plus h. And so it's like there's some random point x here. We don't know what point it is. It's just because it's just an x, right? It's not a specific b. It's just a variable. And then when you do plus h, it does the same thing, right? It moves like a little bit away from x. And then when you do the limit, it does the same thing where you're doing average rates of change between these points. And then eventually it'll get to this same thing that we care about. But instead of being a specific point, right, b is a specific value. Like it's like the number 1 or something. In this one, there's no specific value. It's just a variable x. And so in one, you have numbers in it. And so when you start calculating the limit, you get a number out. And in the second one, you're only going to have variables in it. You're going to have x's and h's in it specifically. And so when you do the limit on those, you end up with an x. And so the one on the left is like this one, right? We did this and we ended up with a number at our other answer. What we'll see in a second here is our new approach is going to have not numbers in it. There's going to be x's and h's. And so our answer is not going to have numbers in it as well. Does that clarify it a little bit? I hope you'll see what I mean when I say it eventually. But the idea is there's specific numbers in the first one, like this, and there's not in the second one. But you're doing the same thing, essentially, is what I'm trying to convey. Does that clarify?
So the first and the third one have actual numbers, but the second one doesn't.
Correct. The first and the third one, you're going to get a number out. The middle one, you're going to get a function out. Yes. Other thoughts? Try not to fret on it too much before we look at an example. And I think hopefully you'll see a little bit more about what I mean. I got to get rid of this stuff though. Okay. Let's talk about notation. So before we actually look at an example, I like to focus on notation just a little bit. Sorry, what was that?
Just go back up for a second. I didn't get the last one. I appreciate that.
So before we kind of move into the example, I just want to point out this notation thing. Depending on the textbook you look at, they sometimes represent derivative differently. And so if we have a function with an x in it, notice how a lot of these things have d over dx in it. That's a notation that means, so d over dx, when you see that in a textbook or in a future math class or in the notes, that means the derivative. So the d in the top means the derivative, and then the dx in the bottom means with respect to x. Right, so one of the confusing things about this calculus business and the rate of change is that you can say the same thing a million different ways in this class, right? So derivative means the same thing as instantaneous rate of change, which means the same thing as d over dx, which means the same thing as f prime or y prime. And we just need to start, my goal in this red box that I just put on here is to try to label all the different ways we might see these things, or at least notational wise, so that hopefully you can reference back to that if you're confused about something when you see in the notes. I mostly use the prime notation, but it's just good to know the other ones. And when we start doing related rates or implicit differentiation, I do start using d over dx a little bit. So just, it's good to know that they're all there. Anyway, I just wanted to point that out. Okay, so let's focus in on the new formulation, right? This is the real thing we're trying to focus in on this page. Most people get confused about the f of x plus h part. And so I do the same thing in pre-calc. So this might seem familiar to a few of you. Let's say we had the function x squared plus 1. Right, that's the function. Actually, is that the example I want to do? What function do I want to do an example of? Maybe we should use... I'm going to make it, let's make it x squared plus 2x plus 1. Let's get a couple x's in there. If I asked you what f of 2 was, I think everyone knows how to do that, right? You just take the x out of there. Here I am removing the x. And when you write a 2 in here, right, when you put that 2 in there, everyone knows that that just means you put a 2 into those two places, right? And you just simplify it down, and that's how you get your answer. I hope everyone knows, and I'm confident that's true. But what I'd like to focus on here is the f of x plus h part. And that notation is the same notation, right? It's the function f with some stuff between parentheses. And so that notation sort of extends to anything is what I'm trying to point out here. Is if you had f of, for example, star, that just means you take the x out and you put a star in. Right? Maybe I can color code this a little bit. So here I have taken the x out, and I've taken it out of everywhere, right? I don't even have it here anymore. There's no x's. And the idea is when you write one into the spot here, for example, it also goes in the other two spots. Whatever you write in the first spot, it goes into the other spots, right? It still has the square. It still has the coefficient 2. The plus 1 still came along for the ride. You're just taking the x out and putting something else into it. You guys with me on that? So what is this then? Just take a second and see if you can check your understanding of this. What is f of question mark? What would that look like? Does it, and you know, this doesn't make any sense, right? F of question mark isn't meaningful, but I'm just seeing, do you know how to plug a question mark into this function? Okay, take a second and just see if you write that down, and then I'll write down the answer in a second and see if you got it right. Right, so f of question mark, just to be clear. And so I'm going to start by just taking the x out. And this is the kind of thing that shouldn't take too long. You just take the x out, you put the question mark in, and so it should look like this then, right?
I see what you're trying to get. Like, you plug it in like that, but like, what part of the original blue box are you talking about?
So what I'm trying to hone into is the f of x plus h part. So let's just do that then, right? So what is then f of x plus h, right? That's the part of the box I'm trying to hone in on. And so what I'm suggesting you do anytime you plug something into a function is just first take the x out. So I'm going to do that same thing I've done a bunch of times already. I'm just taking the x out. And then anything you write into the parenthesis right here just gets into the other two places, even if it's something weird like x plus h. Right? So I write x plus h in there. It goes into the other two places. That's the thing I'm trying to creep towards here. John doesn't look convinced. What do you think?
Sure, I'll just keep following along.
And what we're eventually going to do is we're going to let h go to 0. right? So this is just, I'm just trying to hone in on this one piece of that equation, because it's just going to be one component of this limit, right? And so we want to make sure we nail that sort of confusing part so that the rest of it falls out. Are there other clarificational things I can clarify? We're going to do an example, of course, but can I clarify something else right now?
Will H be defined in the example?
No, H is just going to be H, and H is eventually going to 0, right? So that you're eventually going to plug 0 into H, but it's going to be an indeterminate form, and so we need to use some techniques that we had from class. Right, you see that up in the limit here? H is the thing that's actually going to 0. And so eventually we're going to plug 0 into this thing, but notice how it's in the top and the bottom. Anyway, I'm creeping towards an example, so I'm sorry if people are like, all right, let's see one already, but just wanted to say that. There's also something else I want to say too. Other clarificational things before we keep going? All right, let me sneak in another thing that people oftentimes need to hear. This piece of it. Let's move up here and think about x plus h squared. This is something that people have a real hard time getting correct. So x plus h squared does not equal x squared plus h squared, right? You don't just distribute the square to the x and the h. What you need to do is distribute.
You FOIL?
You FOIL, exactly. Right, and this is, again, don't feel bad if you didn't know this. The reason I'm doing it is because most people forget this. It's something I harp on a lot in pre-calc. It's just one of those things that's very common to make a mistake on. It's not a big deal. But like, this is the kind of thing where I'm taking the time to say it in class. And so it'd be nice if you wrote it down so that when you had a problem, you could look back at it and get it right, right? That's the point. So anyway, yeah, you want to FOIL this and do this kind of thing. And notice that when you do that, you get a slightly different answer. You get x squared and you get h squared, but you get 2xh in the middle. So you'd miss that middle part if you didn't FOIL. And so it's really worth me saying that because, again, it's very, very common for people to miss that. All right, we're ready to do an example, but I've done enough I'm trying to do some algebra background, sort of common algebra mistakes before we look at that. We'll probably just do one example. See if there are questions. I might do a couple. I don't know. It doesn't seem like people are ready to talk about review questions, so I may just keep going. Can I clarify anything else so far before we do one? I just saw that chat. Yeah, nice, Harris. That was a correct answer there. Good. So let's do one. So let's pick a function. I'm just going to pick a slightly less complicated function. Let's just do x squared plus 1. And let's find the derivative using that definition. Okay. And so f prime, we're going to use the limit as h goes to 0 definition. And we're going to use all the things we just talked about right above this. So let me maybe slide up a little bit so you can see some of that stuff. I don't have a lot of room though. So it's going to be this. And then when we plug in the x plus h part, right? So let me just pause here and just point out that this piece of this is like the thing we were just talking about. It's just one piece of that numerator. And so there's more to it, right? But that one piece ends up looking like this. Don't forget to write your limit down. And let me label these components. So this first piece is my f of x plus h. The second piece is my f of x. And as you can see, h is just h. So someone had said, oh, is h going to be a number in there? No, h is just, it's a variable in this case. It's just h. And eventually we're going to plug 0 into there, right? Eventually limit h is going to go to 0. But it's in the denominator. And so we need to cancel out the denominator before we do that. Let me just pause there and see if that looks okay. Again, this is usually the hard part. This is setting up the problem. If this was a test, And this is not on the test Friday. I should point this out. This will be on our second test. If this was a test though, or a quiz, this would be most of the points, or at least like probably 3 out of 5 would just be getting to this step. And then the rest of it is algebra and doing some limit stuff. Can I clarify something about that? Is that okay? All right, I don't see anyone writing, so let's keep going. The rest, like I said, it's algebra. And one key thing here is this minus sign is another thing that people oftentimes miss. So this minus sign distributes and makes both those things negative, right? That's an important thing because the ones are going to cancel. We need those ones to cancel out. And then when we square out the x plus h, that's going to be this thing we just looked at right up top there, right? And so those are the two things that I just want to point out. And so let's keep going. Got the chainsaw buzzing hard right now. So that first part simplifies to that. And then when we distribute the negative, it becomes minus x squared minus 1. So some stuff will cancel. Right. And the whole point here, just like all these limit problems, is stuff cancels and eventually you can simplify it, right? So x squareds cancel and the ones cancel. All right, I'm just going to pause there and see if there's some questions. Does that seem okay? The algebra is all there. It's okay. Okay, so eventually we want to plug h equals 0 in. And just notice if we tried to do that right now, we get 0 over 0. So we're not quite there yet. But we can factor an h out of the top, right? There's an h in both terms. We can factor an h out, which will cancel with the 1 in the bottom. And that's how we end up solving this one, right? So let's go ahead and finish that one off. So let's factor the h out of the top. Right? In other words, this is a factor and cancel problem. The h's cancel, right? That's why, again, this is stuff we've learned in the limit section. If you're wondering, like, how do we know how to do this? We talked about how to evaluate limits, and this is a factor and cancel type question. And the limit as h goes to 0 of 2x plus h. We can plug in a 0 into that for the h, right? And so it's just 2x plus 0, which is just 2x. And so that's the derivative, right? That's f prime of x. And it's a function. And so that's nice because if we want the derivative at any point, we can just plug it into this function. That's the whole goal or nice thing about what we just did. Pause there again, just let everyone catch up and see if there are questions. I'm going to make this a little bit smaller so I can just add one more note at the bottom. But please, please, please ask a question. You know, I want to encourage questions as much as possible. I know I was very frustrated at the start of class, and I hope you can understand why. I'm like, let me know if I was
I'm
out
kind
of
of
line. But,
confused. At the top, like where I think I see that you put the I see that you put what's it called, the
X plus H.
actually, huh? Yeah, I see that you put the x plus h at where the x squared plus 1 was.
Yep.
I just don't see like why.
Because it was asking us to, right? This formula says plug x plus 8 in the function. And so that's what we did. I'm getting a little bit of lag here. Let it finish up here. So there's x plus h on the left in the formula. And then the x plus h on the right is actually doing that. So it's actually plugging the x plus h into the formula. Did you catch that? Looked like my internet skipped there for a second.
Okay.
Right, and then the second part, right, this part, f of x, that's just the normal function. And so we did that too. We just wrote down what f of x was.
I actually got a question about the same thing. Why is the h on the
Yep.
inside of the square? Why wouldn't it be on the outside? You know what I'm saying?
Because
Why wouldn't-
it's being plugged into the function, right? It's like it's giving that notation, which tells us to take out the x
Right.
and put in an x plus h. Right? That's different. It would be outside the function if it looked like this. And maybe I should undo those things there. If we had like f of x plus h, that would be that, right?
Mhm. Right.
F of x plus h. But when it's inside there, it's inside the x squared when you do that.
But the 1 is not, right?
The 1 doesn't have an x, right? So that's why I wanted to put the 1 in there, right? There's nothing to plug in with the x, or with the 1. I mean, there's no x to
Okay.
plug anything into. Just like up
Okay.
here on this example, right? We had 1, 2 x's, but this one did not have an x.
Right.
When we did it here, we got 1, 2 things to plug it into, but this one did not.
Okay. So it falls inside the parentheses and the exponent, right? The square. But the 1 doesn't have an x, so it just isn't outside.
Right.
Okay.
It's the same thing as like thinking about this. I don't know if this is helpful. I always think this is helpful. Just think back to the really, really simple thing, right? You didn't do anything with this 1 when you plugged the 2 in. It's just because it doesn't have an x with it. There's nothing to plug it into. The 1 just kind of comes along with the ride. The thing that gets plugged into are where the x's are. Other thoughts? Those are good. Those are good clarificational thoughts. Shows me you're thinking about this. And it's better to just to think about this out loud now than to try it, a week later from now when you're on the homework and you're like, I have no idea. I don't remember this. Just get it out now. This is great. What else? So, okay. Nothing else? Those are good questions. I'd like to keep going. I think I am. So x plus h equals x. I guess I don't know how many more ways I can say this. And then let me think here. Let me just maybe do a different example. Like, what if we had this 1 over square root of x? That's our f of x, right? If we did f of 2, that would be this, right? What I'm saying is anytime you want to plug something into it, you first take the x out. And so anytime you see one of these problems, you should do this. And then if there's an x plus h in there, it just goes where the x was. I don't know if that's helpful. And sometimes
So
maybe
you always what's it called? You always put the x plus h where the x was.
for that piece of the formula, yes. Yep. That's
Okay,
right.
yes, that makes a lot more sense. Yeah.
So going back to what I don't really know his name, but he was talking about the x plus h squared plus 1. We're
Yep.
only putting the plus 1 on the outside because when we were talking about f of x, it's x squared plus 1, right?
Right. Yeah. The plus 1 came from this. Oops, I forgot I had the thing on. The plus 1 comes from this piece.
And the reason that it's not inside the parentheses is because it doesn't have an x. That's what you were saying? That's the reason it's not in there with the x plus h.
Correct. Yeah. Right.
Okay. Calm.
Other things? So, do I have time to do this? Probably not. I will keep going, but I will pause here and see if there are review questions. I don't know if people wanted to talk about review. Let me just at least point out it's probably not worth keep going at this point, unfortunately. So I will just throw the topics in here and just remind you where this stuff is going to stop on the test. So you don't freak out about this being on the test on Friday. It's not on the test. So I'm just trying to pull up the topics here. There they are. And so it's the last thing on here is average rate of change. Right, so this average rate of change is just the f of x1 minus f of x2 over x1 minus x2 thing. So no limits, not the stuff that we've talked about the last 2 classes. And again, that homework that was originally scheduled for tonight, it's up there if you want to try it, if you want to give it a go after we just talked about this, but it's not on the test. Most of it's just limits, right? So like I tried to break down limits into all the different parts, but it's, if you understand what a limit is and you understand how to do like a right and left side limit, then you should be fine. Right? All these things are it's just kind of breaking those down into all the different components. I'm saying here, bring a calculator in case there's a question about a table. I mentioned I'll bring extra calculators, but it's nice if you have one that you know how to use. Continuity is kind of like the second piece of that, which uses limits. And I'm just going to take questions directly from the homework. So it's not going to be something out of left field. Limits at infinity. This is the thing that the quiz is on that I was kind of frustrated about earlier. I would love to keep talking about that, but in my opinion, that's one of the easier topics on the test. So we can harp on that if you want, but maybe there are other things you want to talk about. And then rate of change is a big topic, but I'm only really going to ask you about average rate of change and maybe the difference between these two things, right? But I'm not going to ask you to calculate instantaneous rate of change on this test. The second test is going to be all about instantaneous rate of change. And we're really just scratching the surface of that. So are there questions that people want to look at? And again, I put lots of review questions on there. I'm happy to do that, or I will just keep going with the notes if people would rather not. The other thing I would like to offer you, a little hesitant to say it, but I'm willing to come on tomorrow evening or whatever and do like a review session. But when I say review session, I mean you've done some studying and you come and get clarification about topics that you need some help with. So thoughts? Do people want to talk about things right now? Are people interested in something to do tomorrow? See, someone had a question about, oh, Gregor asked a question about the homework that we should talk about. I forgot about that. So we can look at some homework questions. Yep, someone just say something?
I was gonna ask about instantaneous rates of change.
Yep, what about it?
I'm kind of confused on it a little bit. How to find it, because I've watched the videos on it, and I even remember going over it. To find it, do we only have to go through x values and y values that are before the before and after? Because
Yeah.
I tried that in the homework, and one of my answers isn't there.
Okay, let me say something about that and you can let me know if this is helpful. And someone asked, is this test open notes? The test is not open notes. The test is closed notes. Let's see here. Another question was, so Janetta, there are 2 different types of instantaneous rates of change. We talked about estimating it, and it sounds like maybe that's what you're talking about. And then we've talked a lot about, especially today, this doing it exactly with the limit. So I'm not going to ask you to do these on the test, but that's what the 2 methods that we've talked about so far about instantaneous rate of change are. And again, remember, it's the slope of the tangent line. That's what it says right here. It tells us how steep the graph is at a point. And so I think, actually, that was not Gregor's question. Let me dig into the homework that a couple people are asking about here. So this was one of Gregor's question, and let me just see what Rashid is asking about. Rashid asked about question 3. Okay. Yeah, so let's look at this one and then we can look at the other one because this has both of them on there. Take a screenshot of this if I can. There we go. And I think I can actually just send this into here and do it that way. Cool. Right, so average rate of change is just using the slope formula. And so this is, and I know this is not Rashid's question, but this is related to the question that Gregor had. So we want to do the f of x, and I guess I'll do f of x2 minus f of x1 for x2 minus x1. And so if we want to do from 0 to 1, I'll just do that one example. That would be f of 1 minus f of 0 over 1 minus 0, right? And so you just look at the graph on these things at 1 and 0. So f of 1 is right here. F of 0 is where we started. And so this is going to be 15 minus 0 over 1, which is 15. And you can see that's the question. It looks like you got right, whoever's this is. This might be Gregor's. Yeah, go ahead.
Sorry, it's kind of tough with this graph though, because you can't see the exact values. I had to try multiple times because I couldn't see exactly what it was.
Which is the trickiest?
Same
yeah,
for some of them.
Were some of them
Same.
funky? Like, let's see, like 2.5. Is that one weird? One looks
Yeah, some of them weren't like exact, like some of them were like 19 and or 21 or something like that.
Does everyone's graph look like this? Does anyone have a different graph? I'm wondering if this is all different or if everyone gets their own. Does anyone have a different looking one? Just curious if we can make some blanket statement about this.
Mine looks the same.
Yeah, that is a little confusing there, huh? Because then if we want to do at 1 Okay, Rashid's not answering me. So what I'll just say to everyone is I will edit this one and maybe.
You actually froze there for a second.
Oh, okay. I was just asking. So Rashid, was that the issue?
It's the same graph.
Okay. So what I'm going to do is I will edit this one and I'm going to add the function values I'll like write the function values into the description to make it clear. Let me also look at this one that Gregor had asked about. Is it 4? Yeah. So this one, I think the phrasing of this one maybe is just confusing. It shouldn't be terribly difficult. Maybe it's slightly annoying because it asks you to do it a bunch of times, but just delete your answers here and take a screenshot. So on this one, it's asking us, so it gives us a function. This is like, you could think of this as f of t if you want to make it look more like the notes, but we have some function and we want the average velocity. So we want to use that average velocity formula again. And then it wants us over the period when it starts at t equals 1 and then lasts different amounts of time, right? So like the first one is from 1 to 1.01 is what they're trying to get you to do. So it'd be like f of 1.01 minus f of 1 over 1.01 minus 1. It looks like, I realize that when I usually have to talk about this one in class because the way it was phrased. Does that clarify that for you, Gregor? I think you were maybe just doing it a little bit differently.
Yeah, it does. That's what I was missing.
And so like the second one, it gets smaller and smaller, right? The second one's 0.005, the third one's 0.002, etc. And so the idea is the answers from this one should be getting closer and closer to some number that you'll be able to write in for there. So in other words, let me just explain this a little bit. This is sort of like, it's looking at the limit as, what do we have here? T's, as t approaches 1 of f of t. No, that's not right. It's evaluating. This is the h one. This is actually what we just looked at. It's a limit as h goes to 0 of f of t plus h minus f of t over h. And so maybe this will help us understand what we looked at today, right? So the plus h part is like you have t plus 0.01, t plus 0.005, right, etc. So you're getting closer and closer and closer to t. And in this case, our t is at the 0.1. And so you're like testing out this limit by making a table almost, doing like for different snapshots, and then whatever it's getting closer and closer to will be the answer to part B. I hope that clarifies it.
That makes sense. Thank you.
That's not exactly right. Sorry, I don't want to confuse people. It's really looking at the original limit. It's looking at the limit as t approaches 1. Sorry, I should have realized this, of f of t minus f of 1 over t minus 1. Sorry, it's doing that version, right? Because you're always thinking about the 0.1 and the point's just getting kind of closer and closer and closer to 1. I mean, they're both doing the same thing, but it really looks more like that. Sorry. Other homework questions or things you want to talk about? Other questions that you want to look at with respect to review? Are people interested in scheduling something for tomorrow night? Anything else?
Could you help me with my version of this question?
Sure.
I'm not sure exactly what I'm doing wrong, but I've tried a couple methods.
Is that Simon?
So
is that Simon talking?
What?
Is Simon asking the question? Sorry, I'm not looking at
Yeah, that's me.
Just need to pick yours out. So what do you which parts are you getting wrong, I guess? Let's see.
I'm getting the last part wrong.
So what are these numbers actually equal when you plug them in? Like you're getting that they're correct in here, but when you do that out, what do you like when you? What's the best way to say this? How do I draw on this? Am I drawing it? No, I can't. What do you get when you do this?
Wait, Dr. Levy?
Yep.
Are we allowed to head out? Because I gotta go to a lab.
Yeah, I
Wait.
mean, there's a minute left, but hey, you get out of here. Yeah, the class is ending though. Yeah.
All right, bet for sure.
Take care.
Thank you.
What do you get when you do those out? Like the actual values.
It's something like 3.8. It's like approaching like 3.8 and 3.9 around there.
So, you know, we're gonna need it to be a little more exact. I can bust out my calculator if we need to. Where is my calculator? It's somewhere on my messy desk here. I haven't looked at it in a while. Oh, I can just use my computer, of course.
I have my my TI-84 on me, but that is so many digits. I don't know if I.
Don't worry, man. I got it. Jeez. Let me know. I can do your test for you too on Friday. Maybe something like that. Maybe let's try 3.8584. Money. So yeah, class has ended. But I'm happy to stick around with other people who wanted to talk about some stuff, do some more homework, look at review, could do Simon's homework, whatever.
How did you end up getting that last answer? I'm sorry, I was trying to follow along and
I just plugged these numbers in to a calculator.